Magnetic Cheerios? Why do floating Cheerios attract each other? Let's join a Zoom session with Professor Skeptic and his students to find out.
Who has a question?
Sir, are you eating marshmallow peeps for breakfast?
You have a problem with that?
No, sir. But, sir, isn't that unhealthy?
What's even more unhealthy is questioning your professor.
Dude, I eat Cheerios for breakfast, man. I noticed that they are attracted to each other, like magnets. I'll share a video I took, man. See how they move toward each other, dude? Like magnets. Do you know why they do that, man?
Of course I do. It's called the Cheerios Effect. I'll share a short video lesson I made about this. Cheerios floating on milk migrate toward each other. There is obviously an attractive force that pulls them together. What physical mechanism generates this force? It turns out there are two forces working together: surface tension forces and pressure forces. It works with other objects too, so let's examine a simpler two-dimensional case, namely floating circular rods. Consider one floating circular rod where the material is lighter than water. We'll let the rod material be hydrophilic, which means water is attracted to it and it wets the material. The opposite is hydrophobic. Since the object is lighter than water, there's a net buoyancy force up. In this case, surface tension acts down, where sigma s is a force per unit length. In this case, the net surface tension force is down, and these two forces balance the weight. This curved liquid surface is called a meniscus, and phi is the contact angle between the tangent to the material and the meniscus where it contacts the material. This contact angle must be constant for a given material and liquid. Now suppose we have two circular rods floating near each other. The liquid surface between the two rods rises slightly, and the point of contact moves up along the cylinder. Since phi must be constant, the surface tension force must tilt to keep phi constant. The net surface tension forces on the two sides of the rods are now not balanced. The horizontal component on the right is bigger than that on the left. We'll call that one T middle. The net result is that the surface tension forces pull the rods toward each other. Now consider pressure. The pressure along this dashed purple line at the surface at infinity is atmospheric everywhere in the liquid, since it's quasi-hydrostatic. The pressure above this line is lower than atmospheric pressure, and since the liquid level is higher between the rods, this subatmospheric pressure extends farther up, and so P middle is less than P left or P right. Net pressure forces also pull the rods toward each other. I created an animation of this. As the rods start moving towards each other, the surface tension force keeps tilting. The liquid in the middle rises. Thus both the pressure and the surface tension forces pull the rods together until they touch.
Awesome, dude. Thanks.
Excellent explanation, sir. Thank you, sir. Enjoy your peeps.
Yeah, enjoy your Cheerios. Yeah.
In summary, a floating object is subjected to both pressure and surface tension forces, which combine to balance the object's weight. Since the contact angle has to remain constant, the meniscus gets distorted as the two objects approach each other, and the liquid between them rises. This leads to an attractive force, which in the case of objects that are lighter than water, both surface tension and pressure forces cause this attractive force. Thus the two floating objects move toward each other, kind of like magnets. This explains magnetic Cheerios.
Thank you for watching this video. Please subscribe to my YouTube channel for more videos.
1, 2, 3.